Next example, we have this circuit, which is 1 and 2 are synchronized. So when S1 is open, S2 closes and vice versa. So S1 has been open for a long time before closing at t equals to 0. So find IL of t for t greater than 0. So at t less than 0, our circuit is at steady state. Switch 1 is open, switch 2 is closed. So we have two separate circuits. So our VC at 0 minus is equivalent to, so using voltage division, we have 5 over 10 times 240, we have 120 volts. So VC at 0 minus is equal to VC at 0 plus. Now our IL of 0 minus is equivalent to 60 milliamperes, which is just equivalent to IL of 0 plus. So now we have our initial conditions. At t greater than 0, we have this circuit. So looking at the circuit, this does not qualify as a parallel or a series RLC circuit. But we can transform this circuit into a parallel RLC circuit, so by using source transformation. So using source transformation, we have, so now we can directly solve for our alpha, which is equal to 1 over 2RC equal to 40 rad per second, or omega naught is equivalent to 1 over square root of LC equal to 50 rad per second. So our alpha less than omega naught. So our circuit is an underdamped circuit. We have our IN just equal to e to the negative 40t, where 30 is our WD, equal to square root of omega naught squared minus alpha squared. Since the circuit involves a source and an independent source, our complete response is composed of the forced response and the natural response. So for the forced response, looking at the circuit, our forced response is equivalent to 48 milliamperes. So in order for us to solve the coefficients A and B, we need to have two initial conditions. So we already have the IL of 0 plus, which is 60 milliamperes. So we need the IL dt at 0 plus. So for us to get the value of the IL dt of 0 plus, so the voltage at 0 plus can be expressed as L DIL dt at 0 plus. DIL dt at 0 plus is equal to 1.5 amperes per second. So now we have this initial value. So our complete response, IL of t is equal to 48 milli plus e to the negative 40t times a cosine of 30t plus b sine of 30t. So at t equals to 0, our equation becomes 60 milli equals to 48 milli plus A plus 0. We can solve for the value of A is equal to 12 milli. Having this equation, then getting the value at t equals to 0, so our KIL dt at 0 plus is equivalent to negative alpha A plus W for omega d B. So getting the value of B is equivalent to 66 milli. So our complete response is 48 plus e to the negative 40t 12 cosine of 30t plus 66 sine of 30t times u of t milliamperes.